So I'm going to go over synchronization mechanisms from chapter 6. Specifically, I'll focus on Mutex this time, which stands for mutual exclusion locks. Again, locking is just a synchronization mechanism that we use for concurrent programming. It ensures that we don't have any race conditions and things like that. Specifically with Mutex, you have two functions that are about acquiring the lock, be able to enter your critical section, do any sort of modification to the shared resource, and then upon completion, you're going to release the lock that you had. So before I dive into the actual code or anything like that, I want to share the resources that I use to help me come up with everything. So I'm using the pthread library. You're going to be using that as well. This mixes both actual threading, like creating a thread, and then you also have all the different functions for actually going through and creating a lock. So you'll use like the pthread mutex initialization for a mutex locks, and this documentation basically helps you go through and tells you if you're going to initialize it, you're also going to need this function to destroy it. Gives you a description of the actual function with the parameters that it requires, tells you the return value it's going to have. And another nice thing about this is that if you're going to run this specific function and if it fails, here are the different error codes that you can use. These error codes give you more meaning versus like the usual 1 and 0 for success or unsuccess. Instead, this tells you if you actually you gave an invalid for the mutex. Okay, so this is also linked in your project for you to use. Now let's go and give you an overview of what it actually looks like. So over here, we'll be creating two threads. Each will then try to increment a shared variable. I'm going to use mutex to protect the critical section. Again, this is ensuring that only one thread can modify the counter at a time. And then each thread will also print its ID and the value of the counter as well. So over here, you see that we created two threads. Here's the first thread, which the ending is 376, which is different from the 816. Tell you that we have two different threads that we created and we were successful. So we're trying to acquire the lock. We were successful. We started at a 0 counter. We incremented that global variable. Then you have the second thread that comes in and tries to acquire the lock. The first thread actually releases the lock. It's trying to release it, trying again to release it, but then the second thread was actually able to acquire the lock. We only have one lock here, so therefore they have to share it. And it's mutual exclusion, as in once one has the lock, nobody else is able to acquire that lock until it voluntarily gives up. So here the second thread was able to acquire it. It incremented the counter, then it was releasing it, and then it released it. And our final counter is 2. And then finally we were able to deallocate all the resources that we were using back to the OS. This is lock that we were doing that. Alright, now I'm going to go through the code. Obviously, before we start with anything, we need to include the necessary header files. The first one is including for input-output, thread management, as well as locking. And then we're using this for sleep, trying to simulate the critical section implementation without actually implementing it. That's why this is a toy example. And then this one is where we have all of those error codes. Alright, so let's start with our global. So we have a mutex to control access to the critical section. So this is where defining those. Then we also have our shared variable that will be where each thread is trying to increment it. And then from here, we'll go into our main function where we are going to initialize our mutex. Then we're going to check that we were successful at actually initializing the mutex, and we're going to have a success or a failure error code to give us more meaning. And then we're going to actually try to create the two threads, and we first try to create the thread. And if we were successful, so thread 1 was we created thread 1. If we were successful, we would immediately call the increment function, which is above. We'll go over that in a minute. But before I do that, I'm going to check again, was I successful at creating that first thread? And if I was not successful, then I'm pretty much going to say that I failed. I'm going to destroy the mutex that I tried to initialize it because I need to deallocate things. And then I'm going to return an error function. So this is the first thread. Now we're going to say we're successful because you saw that we were. Because we're successful, we're going to now go into the increment function. And the increment function essentially is trying to acquire the lock. And we're going to test, did we actually successfully acquire the lock or not? We shouldn't have any return function since this is a void, but I did it for visuals. So say that we were successful, so we acquired that lock, then we immediately enter our critical section, and we're going to increment that global variable, and we're going to try to simulate some sort of work. This is where we're just putting it to sleep. It did its magic, and now we were finished. The thread's going to release the lock, and we're going to attempt to release the lock, and we're going to check that we were successful in releasing the lock. See how you barely write any code? Because all you're doing is literally calling a function that's already built for you. Most of your code is checking were you successful or not. And then if we were successful, we just state that the specific thread was successful at releasing the lock. Then you go back to the main, and then you run the same simulation on the next thread, which is our second one. Again, calling functions that already were built for us, checking that everything was successful. If it was not successful, we terminate. If it was successful, we'll go back to our increment function that will then try to acquire the lock, then try to increment the shared variable, simulate some sort of work, then release and return. Then you're waiting for the threads to finish. This is trying to join. Essentially, this is saying it was completed. Cool. If it was not, again, more error handling. You do this for thread 1 as well as thread 2. And then finally, you say, okay, since we had these separate threads making modifications to our shared variable, we see that we have, this is our final output. So our final output should be 2 counters. And then we're going to call the function that destroys the mutex. We're also going to check that it was just destroyed. And then we print out that yes, everything was successful. And then you're going to return exit success. Okay, I hope this was helpful. And here's the final output.